Okay, this video covers the 2018 official AP practice exam, number 6, and we're going to emphasize the 2020 test. I believe that all of number 6 could be represented on the 2020 test, although I do think part of this is probably a little bit long for it to be on the 2020 test, but we'll go ahead and work the entire thing. So we're given a curve with the equation 2 times x minus y is equal to 3 plus cosine y. And they also tell us that dy dx, the derivative of this function, is always between 2/3 and 2. So part A says show that dy dx is always 2 over 2 minus sine y. Okay, so we just need to use implicit differentiation, solve for dy dx, and see if it matches what they told us. So let's, excuse me, let's distribute the 2 here. We've got 2x minus 2y is equal to 3 plus cosine y, and we need to differentiate that with respect to x. So the derivative of 2x is just 2, minus the derivative of 2y would be 2 times dy dx. The derivative of 3 is 0. And the derivative of cosine y is minus sine y. But don't forget, this is implicit differentiation, so the derivative of y is dy dx. I'm going to push all the dy dx's over to the right. That'll make them positive, so we'll have 2 dy dx minus sine y dy dx. Let's factor out a dy dx, so that's going to be 2 minus sine y dy dx, and then solving for dy dx, you'd have 2 over 2 minus sine y is equal to dy dx. So they gave you the answer on this one, and you had to prove it. And so it's not so bad. I think that that is very much doable. For my students, anyway. So let's erase this. Go ahead and pause the video if you need to. And we'll take a look at part B. Okay, so part B says we're always negative pi over 2 to pi over 2. So looking at the unit circle, make sure you have your unit circle handy on AP test day, but between negative pi over 2, this is quadrant 1, this is quadrant 4. What that's saying is that the point P is always in quadrant 1 or quadrant 4. So there's a point P on the curve through which the tangent line has a slope 1. Find those coordinates. Okay, we know that the slope of the tangent line is going to equal dy dx. And it says this slope is equal to 1. Well, we figured out that dy dx in part A was 2 minus sine y, 2 over 2 minus sine y, excuse me. We know that's equal to 1. So we can solve for y here. So we'd have multiplying both sides by the denominator, 2 is equal to 2 minus sine y. Let's bring the sine y over to the left. Bring this 2 over to the right. Sine y is equal to 0. So where is sine 0? So again, have your unit circle handy, but you know that sine is 0 at 0. So y is equal to 0. So now how are we gonna figure out x? We plug in our y value into the original equation and solve for x. So I'd have 2 times x minus 0. So again, the original equation right here is equal to 3 plus cosine 0. So that's 2x is equal to 3 plus, what's the cosine of 0? All right, again, you're going to have your unit circle handy, right? So that's going to be 1. 2x equals 4. X is equal to 2. So the point is x is 2, y is 0. All right, that's doable. Okay, so I'm going to erase this part, and we'll take a look at part C. I do think that part C is a little bit on the difficult side, but you want to go ahead and try it. You know, on the 2020 test, work the ones you can work, and then come back to the ones that you struggle with and see what kind of partial credit you might be able to get. All right, part C says determine the concavity. And again, this is in quadrants 1 and 4. And give a reason for your answer. So how do you get concavity? You have to take the second derivative. So we know that dy dx is equal to 2 over 2 minus sine y. Again, that's from part A. So what's the second derivative? All right, this is pretty complicated, this one. So it's the bottom, 2 minus sine y, times the derivative of the top, 0. Minus the top, 2, times the derivative of the bottom. Well, the derivative of 2 is 0. The derivative of sine is cosine, so negative cosine y, but don't forget, times the derivative of the block, dy dx. Okay, so this is, you've got a y there, not an x, so we have to do the dy dx. That's what makes this thing a little bit of a pain. All over the bottom squared, 2 minus sine y, all squared. Okay, so the 0 makes this whole part go away. Negative negative is a positive, so what you would have is positive 2 cosine y. And then we know that dy dx is just this, so I got to plug that in. 2 over 2 minus sine y. Okay, so what you can do is bring that 2 minus sine y downstairs, and then that'll make it cubed. So on top you'd have 4 cosine y, 2 times 2 is 4, over 2 minus sine y, all cubed. Again, I'm bringing that part downstairs. Okay, so you could look at the values in the first and fourth quadrant. Cosine's always positive. And then sine is always going to be less than 2. Right? The biggest value is going to be root 3 over 2. Okay? Actually, the biggest value is 1. So 2 minus 1 is always positive, right? So the denominator's also always positive. So we know that 4 cosine y over 2 minus sine y all cubed is always greater than 0. So it's always, what's the shape? Always concave up. On the 2020 test, don't write CCU. They might not have any idea what that means. They probably do, but my class, we can just write CCU or CCD for concave down. But you want to go ahead and spell it out on this test. I think that one was a little bit hard. But, you know, they're probably going to give a couple of hard spots on this. So, you know, you'll probably have a couple of parts that are easy and a couple of parts that are hard for each of the questions. All right, so let's finish this up. So it says, part D says that, again, we have this equation, and we're on that closed interval 2 to 2.1, and it's differentiable. It's continuous and differentiable. We want to use the mean value theorem to show that, and you see what that is. All right, so again, they've given us the answer. We got to prove So in this case, we're going to use this. We know that dy dx is always between 2/3 and 2. So the mean value theorem states that f prime of some point c is going, the slope of the secant line is going to equal f prime of c somewhere at c. So the slope of the secant line is just f of 2.1 y2 minus y1 over 2.1 minus 2 over x2 minus x1. Okay, so we know that dy dx is always between 2/3 and 2. Okay, so you'd have 2/3 is less than or equal to f of 2.1 minus f of 2. 2.1 minus 2 is 0.1, right? And that's going to be less than or equal to 2. So if we just multiply the whole thing through by 0.1, 2/3 times 0.1 would be 2 over 30. So that's 1 over 15. And then 0.1 times 2 is 0.2. That's 2/10, right? Which is 1/5. So you know that the slope of the tangent line, which is f prime of c, has to equal the slope of the secant line. That's this, right? This is the slope of the secant. And then we just go through the math there and right? So not hard if you know what the heck to do. And so I went ahead and worked it for you, so you've seen one of these in case you get something like this. So that concludes our video on number 6. We'll move on to a different practice exam on the next video.